So you might be wondering what the heck is going on and why do I have a floating X walking around my screen, actually my console. And what I'm actually doing is playing a game which I just wrote. It's called Fluffy the Cat. And you are basically Fluffy, a cat who is looking to get out of a maze. And I wanted to combine everything we've learned so far into a sort of like an interactive game. And this is what I came up with. It's something which I've done in previous years as well, but never in C. It was always in object-oriented languages. But yeah, it went well, I would say. So I want to show you guys how to create such a game. Let me just try and actually finish it so you know what the end game is. There we go. So yeah, I get to pick how much of the maze I see, and the point is to reach its end, and that end is marked by a letter. Oh boy, I really did make it too complicated. There we go. Okay, so now when I hit the F, the game should end. And meow, I reached it per. Great. So let's see how we actually write the code for this. So first off, let's just create a new project. Where is it? There. No. What? Oh, there we go. Jesus. And let's name it Fluffy the Cat V2. Okay. And let's just close this. Nope. Okay. So I'm going to be copying the level I created so I don't have to work on it again. How do I? Yeah, I think I need. No, I can just add it from here. And there we go. Okay, now taking a look at it. Wait. Yeah, it kind of looks like this. So I will need to know in advance how many rows and how many columns I have. I have 30 rows and 50 columns. So we start off from that. Everything which is a star is actually a wall, and you won't be able to walk in walls. S indicates the starting position, and F indicates the ending position. And everything in between you can walk on. So these are paths. So I'm going to be creating a header file first. No, let's just do this. Yes. And I'm going to be calling it maze reader.h, which is the header. And here I am going to need to include a few things, and I'm going to copy them from here. I said copy them, actually just cut them, I guess. There we go. And I will define level as this. Fluffy maze 1.txt. So I just want to create like a string well, it's not a variable because it's a constant here, for the file name which contains the maze. Now I said that S stands for start, F stands for finish, and so on and so forth. I will actually need a few constants for this. So static constant char start is gonna be S. Static, I'm just gonna copy these. Finish is gonna be F. So I'm predefining everything because I'm gonna need them in the code as well. There's also a wall, which is this. There's also gonna be a path, right? And then a player. Let's just mark this as X, and then finally void. And this void indicates nothingness. I mean, what gets printed outside of the visible spectrum, okay? Now, moving on, I'm gonna need some structures. And I'm for sure going to need a pair structure, something that indicates position or size for two-dimensional things. So type def struct, and let's just call the variables x and y, and this will be a location and also a dimension. So I know it's a bit confusing because you don't usually mark dimensions with x and y. You usually have length and then width, but let's just leave it at this for now because I'm mostly gonna be using location. So it's gonna be whenever I want to create a new structure like this, I'm gonna be having location L and then L.x and L.y and so on. And as for dimensions, I'm gonna know that x is gonna be my my height and y is gonna be my width. Let's just leave it at that for now. And also I am gonna need a structure to represent my maze. So type def struct, let's just put it down, char blocks. So I'm gonna need a matrix of blocks because, well, basically this is what I have here, a matrix of blocks, of characters, I'm sorry. I named it blocks. I need a dimension for it. So this is gonna be of type dimension. Let's call it dim. And I'm also gonna need a location of Fluffy of the player. So the current location of the player is indicated by this Fluffy variable inside the maze structure. Okay, and I think I'm just gonna need this, a function which returns a maze, which returns this, and it's called read maze. Great. Now that I have this, I'm going to need to create a new file, which is going to be a C file, and let's just name it maze reader. Okay. And this will include also the main will include maze reader, and for now maze reader.c will also include maze reader. Okay, so let's implement that function read maze, and we know that we can open a file simply by using something like this, equals f open of level, which I defined in mazereader.h, and I don't really need to write anything, so I'm just gonna be opening it with the read permission. So let's just check if everything is fine. Yeah, that's all right for now. Okay. So I will need to first to read the dimensions of this maze. So dimension maze dimension equals to let's just create a function for this, read dimension of the maze file, and I will need a function called read dimension, which returns a dimension, and it takes as input a file object, a file pointer actually. So dimension dim, and I'm gonna be using fscanf for this because I already know the format. So I know that I'm expecting two integer numbers. So fscanf from the file f, I'm going to be having two integer numbers, and also afterwards I am going to be having a new line. And if I don't put this new line here, the next character I will end up reading will actually be this new line. So I have to make sure that I'm reading it right now so that it will be skipped later. And I'm going to be putting these inside dim.x and dim.y, and then returning dim. Now let's make sure that we have what we need. Dimensions here, and maze dimensions.x, maze dimensions.y, build. I know the control reaches, and okay, let's just fix this as well. I'm gonna need a maze object, something like this, and return m. And this way I won't have that warning. Okay. And of course, I'll need to somewhere call this read maze function, and it's gonna be in main. Read maze, and hopefully it will just print out these things. And it does. It just triggers on my other monitor. It does. So it works. Everything is fine until now. We don't need this anymore. But we will actually need this maze initialized. And what I mean by that, I have this maze structure containing this matrix, this double pointer, which basically is a matrix of characters. And I need to initialize it. And I know exactly how many characters I have because I've just read them. I've read them, and it's basically just dimension, the maze dimension dot dim dot x and dot y. Oh, speaking of which, I have to do something like this. So let's just move this to the top, and m dot dim equals to maze dimension, because I've read this dimension in this function. So actually I don't even need to declare this object. I can just write m.dim equals read dimension. How's that? That's nice. Okay. Now I need to initialize the rest of the things, and that means I need to initialize this. And let's just write a function for this. Let's name it initialize maze. Initialize maze, and I'm gonna be needing dimensions for that. And let me just do this, because it's gonna be a bit simpler and you'll understand what I'm doing. So I wrote a function, initialize maze, and I'm expecting that function to return a maze object, and actually to accept as parameters a dimension structure, this. So let's just write that. Maze, initialize maze, I'm copying it from here, dimension dim, and I want this to return a maze. I'm gonna name it m. Now m.dim, I know that it's gonna be this. I'm initializing that dimension object with what I'm passing as a parameter. And the blocks will simply be m.blocks equals to char malloc size of char times dim dot x. Again, this is the number of rows, and I'm gonna need a for loop for all those rows. I want to initialize a fixed number of columns. So m.blocks of I equals to char malloc size of char times, you've guessed it, dim.y. and then I'm returning m. Whoopsie. There we go. Now let's format the code. All is well. So in this function, in this initialize maze function, I both initialize the dimensions variable of the maze and the blocks. So I'm left with actually reading the contents of the level. Now, after a few trials, I decided that it's actually best to read everything character by character. So I won't be reading a whole line. I'll just read the whole, like, character by character, the whole thing. So I'm gonna have a character object variable called block, not black. And I'm gonna be using 2 manual counters for this, and you'll see what I mean in a jiffy. So while this block, which gets the value f get c from my maze file, is different to end of file, so until I reach the end of the file, I need to do actually 2 things here. First off, if, and this is my fail-safe, if block is equal to \n, so if I reached a new line, and this is very important, what should I do? Well, this indicates the column I'm at. No, actually this should indicate the row I'm in, and J indicates the column. So if I reached a new line character, which would basically mean here, for example, or here, and you won't see these as characters in a text file, but just so you know, they are there. Okay, so I will increment my row counter and reset my column counter. So I will want to basically start the next row here from the first column, and automatically, because I'm reading everything sequentially and with f get c, and well, because things get read sequentially anyways in C, I need these counters for something else, not for actually reading from the file, but to store everything properly. Okay, if not, then I will do this. m.blocks of ij equals to block, and I'm incrementing my column count. And I don't want to miss this. There's also one more thing which I want to initialize here, and that is this, the location, the starting location of the player. So if my block equals to start, and I've defined this here, start is s, and it's very important to have it a unique character. It doesn't have to be s, but it needs to be unique. If block equals to start, then f.fluffy.x equals to I, and m.fluffy.y equals to j. So let's see what we did here. Well, if the current block I'm iterating, and which I've just reached, is the start block, then my maze, the position of Fluffy inside my maze, will have the row equal to I, which is my row count, and the column equal to j, which is my column count. And well, that's about it. Is it? No, I need to close this. Before returning m, I need to f-close maze file. Okay. Now, how do I know if everything is right? Well, let's just print everything here. So maze m equals to read maze. And so let's write 2 for loops. For int I equals to 0, I smaller than m.dimension.x, and this will be my row count. And I'm gonna need something very similar for my column count, but it's just gonna be j, and j is gonna be smaller than the other dimension, y, and j++. Printf, I'm gonna be printing a character, and that's gonna be m.blocks of I and j. And when this is done, I'm going to be printing a new line. Let's format and see what we get. Ta-da! Okay. Something is amiss. What am I missing? This gets printed way too low. So I might have a new line uncaught somewhere. Aha, I found it. Actually, it took me a while. I need to make sure that if I reach a new line, I jump over everything that is below. So I need a continuous statement here. Okay, I don't want to exit the whole while loop. I just need to make sure that nothing gets executed after this continue. So the next iteration will simply and automatically appear, and voila. There we go. And yeah, this is basically how my maze looks. Okay. So this is the first part of the game. Reading everything from the file. Okay. So we don't need this anymore. I'm pretty sure it works. And what I need to do now is make sure that I can move that cat, Fluffy, in order to help him reach the end. And I'm gonna start by creating two files. First of all, I'm creating another header, which I'm naming mazegame.h. And let's see what we have here. Well, first of all, I'll need to include mazereader.h. So include mazereader.h. And also, I'm gonna need a few constants here. First of all, as you could see before, I could choose how much of the level I get to see around me. So that's gonna be a view distance constant. So static, and it's an integer, static constant integer view distance. And I'm gonna initialize it to 3 for now. It doesn't really matter. And now what I need is a few hotkeys for my movement. And I know that ideally you would actually bind your arrow keys to move around, but it's a bit more complicated in C. So it works fine in other languages. It's just a bit more complicated in C, and I don't want to get into that. So I'm just going to bind W, A, S, and D. So static constant char up is going to be W. And let's copy this. Left is going to be A. Down is going to be S and lowercase s. And left, and actually right, is going to be D. Okay. And I would want to have a function called play, which takes as parameter a maze object and returns nothing. Okay, and of course, after my header file, I want to create a C file called mazegame, which will include mazegame.h, and my main file can now simply include mazegame.h, and I'm gonna be able to write something like this: play of M, or even simply play of read maze. Okay, undefined reference to play. And this is because I haven't implemented it yet, but I will. Doesn't have to return anything, just printf. I am playing the game. And all works fine. Okay, so how do we go around this? First of all, I want this play function to just print my board out. So let's just write a print board method for now. So this print board should take the maze as a parameter. And so because I want to put things below, I want this to be here. In order to reference it from here, if I just compile now, I'll be having implicit declaration of function print board. So in order to make sure that this play function knows that somewhere in this mazegame.c there's a function called print board, I need to declare its header in the mazegame.h. There we go. And basically, you should, I don't know if I mentioned this before, but this include mazegame.h. Well, the gist of it, what it does is just copies this code and it makes it appear here. And instead of putting this here in mazegame.h, I could be putting it here. And the effect would be exactly the same. See, no warnings. But I prefer having my function declarations in the header. Now, what should this print board do? Well, first of all, it should clear the screen. And there's actually a command for this. It's called system, and it takes an argument, a string. And if I put CLS here, then it will clear my screen completely. And let's take care of our printing. So I need to for loops. For int equals to I, and this corresponds to the rows. Okay. And one for the columns. That's going to be J and Y. Okay. Now, I'll need to write a few other things. So first of all, so if my current position, which I want to print, is within range of Fluffy, then I will print it. And I will print this thing, m.blocks of I and j. If it's not in range of Fluffy, I will want to print void. And again, I declared this void variable here, and it's just an empty character. Okay, so I don't have this function yet. Is within range of Fluffy. But who is within range of Fluffy? Well, my current coordinates. So if you remember, I played that game before, and I could only see a part of the whole board. So first of all, as a parameter here, I will need to provide Fluffy's location. And second of all, I will need the current location, and I could be passing something like I and j. However, I want to actually write a bit of less code, so I'll be doing this: location current, and current.x equals to I, and current.y equals to j. And basically, I created this current structure. I assigned the x position to I, which corresponds to the current row I'm in, and the y location to j, which corresponds to the colon. And here I'll be passing current. Oops. Okay, now I'll get an error. Undefined reference to is within range of Fluffy is not a problem. Let's just implement it here. So void is within, is within range of Fluffy. And it takes as parameters to location. So location Fluffy and location current. Okay, great. Again, I have to do the same thing. I have to put it here, and it takes, let's just copy that. And it's not a void, by the way, it's an integer. It basically returns a comparison, the result of a comparison. Now, is within range of Fluffy. How do we calculate this? Well, quite simple. We use the line distance formula. So what is the distance between 2 points in 2D space? And after a very short Google search, you'll find this. So the distance between 2 points is square root of the coordinate x of the first one minus the coordinate of x from the second one, all squared, plus the same thing for the y coordinate, all squared, all underneath the square root. So how do we write that? Well, it's quite simple, really. Let's just create a distance variable, double dist equals to square root of something, and I will need this square root, so that means I need to include math.h. Great. Now it's square root of the power of fluffy.x minus current.x all to the power of 2 plus power of fluffy.y minus current.y all to the power of 2. Now this is the distance from Fluffy to current, and I need to return whether or not this distance is smaller than this variable view distance. I defined it not here but actually here, and it's 3. So in case I am at most 3 units away from Fluffy, then I will get to see that that character, that location on the board. If I'm further, then I won't, and the void gets printed. So let's compile. Everything is fine. Great. So that takes care of print board for us. So now it should actually print our board. But it doesn't, not properly at least. So let's see what's going on there. Of course, I've missed this. So I need after every row to print a new line. And yeah, now it's fine. So I get to see 3 so I get to see 3 units away in distance from Fluffy, and let's try to change that to something bigger like 20. So 20, there we go, and voila, I get to see a lot more. And you'll see that it kind of resembles a circle, and that's normal because, well, if I were to put Fluffy here, let's just do that. Let's just change the location of Fluffy from here to just here in the middle, just for tests. And there we go. A very cute circle, sort of. Let's make it a bit smaller. So view distance of 9. There we go. Great. So yeah, it looks more like an oval than a circle, and that's just because things on the vertical line get printed far off from one another, like further away from one another than the ones on the horizontal line. So you see the distance between this and this is a lot smaller than the distance between this and this, which is above. So that's why it kind of looks like an oval, but it's actually a circle. Okay, so now that's working properly. Actually, I'm cutting the video here just so I can show you that there's a shorthand writing technique in order to not write the whole current, like location current thingy over here. You can actually assign it in line like this. So you have the type of the object, the type of the type of the structure you want to cast, location, and then here you would have the two variables in the order they appear in the in here, and actually here, like location is X and Y. This is the order, and here I'm putting I and J, and this is a shorthand of this location current, and current dot X equals I, current dot Y equals J. So instead of putting current here, I can just put this, and then I save 3 lines of code. Okay, and let me just, so it compiles perfectly and it works, but let me see if it works without that location. No, unexpected. So you need this cast in between. So yeah, that's about it. Let's see what else we need to do here. Well, first off, after printing that board, I need to catch all my desired moves in a while loop. And I don't want the game to end unless I give it an exit condition. So an exit sign. So I print something, I press a button or do something very specific that will indicate, hey, I want to end the game. It's either going to be ending then, or it's going to be ending whenever I find what Fluffy is looking for. So let's just create a variable called exit and initialize it to 0. And while not exit, while this variable is 0 or, well, not 1, we will do a few things. And actually, let's just write some code. We will want to capture a move. Now, let's just put a switch here, switch on the move. And for every move I make, I will need to do something different. So for example, if I press W, then I will move up. So let's just write that. Case W, printf, moving up. And let's just and also we need to not forget about this break. Now I need 4 more things. A, which is move left, S, which is moving down, and D, which is moving right, and also E, let's just put it E, which is exiting game. And in case I press E, then exit will become 1, and that's about it. Am I have this? Oh, what the hell? Okay, I don't need these over here. This suffices. Yes. Okay, let's see what is going on. Case label not within a what? Oh, there we go. This is declaration. What? Expect a declaration at the end of the input. What? What am I missing, guys? Aha. So yeah, I'm actually missing this. Okay, now compiling. All is well. Implicit declaration of get ch. Yes, this get ch, let's put it here. Include con io dot h. No. Just not running first and compiling. All is well. And let's put Fluffy back where it belongs in the beginning here. Okay, so we won't get to see the board for much because now whenever I press these keys, I will either be moving left, up, right, down, depending on what I press. And finally, if I press E, the game exits and breaks. So this is exactly what I want. However, I don't want things to be printed, but for each of these, I will want to change the position of Fluffy. But before doing that, let's make sure we have other things here. So after this switch statement, if we have reached the end of our maze, then we clear the screen. Oops. And printf something like meow. I reached the end per. And also make sure the game exits. And else, if I haven't reached the end, I will just want to print the board again. Now I have a function which I didn't create yet, reached the end. And if I compile, I have undefined reference to reach the end. Let's just put it here. So it's again going to be an integer function, returning function, reach the end, and it's going to accept the maze as a parameter. Let's compile now. All is well. No. Oh, right. I also need to implement it. So int reach the end, it accepts maze as parameter. So what is my ending condition? Well, quite simply, the current block which Fluffy is in coincides with finish, right? With this thing. So basically just return m.blocks of m.fluffy.x and m.fluffy.y equal to finish. So let's think about it a bit. How can it be so simple? Well, this blocks variable, this contains basically this, okay? It contains the whole matrix of characters. And that means it also contains this f. So this f is on line 25 and column, well, roughly 40, I think it's 46. So this would be 49, 48, 47, 46, 45. So it's line 24 and column 45. So at blocks, m.blocks of 24 and 45, I will actually have the value f, right? So great. If Fluffy is also there, so if the position of Fluffy, and this represents the position of Fluffy, if Fluffy is there and there is a finish indicator, then that means I have reached the end. If not, then that means I haven't. So let's test that out a bit more simply. I don't want to walk all that way. Let's put another finish indicator here, right in front of Fluffy. Oh, wait, I can't move Fluffy, so that makes no sense right now. We will test it a bit later. So compiling, everything works just fine. Now, we have just a few more things to do. Basically, making sure that Fluffy moves. And, well, it's really not that difficult. Let's create a function and call it change Fluffy position. And this should be a void function, change Fluffy position. It should accept a maze parameter and a direction. And let's call this function everywhere here. So change fluffy position. We pass the maze and direction up. Oh, by the way, I cannot do this, unfortunately. I wish I could, but C doesn't let me. So in case I want to put this up here, which is actually a static variable here, in case I want to do that, I get this error: case label does not reduce to an integer constant. Well, maybe this will work. Could it work? No, it doesn't work. So basically, I can't use variables here in switch statements. Maybe, could it be that if I define up as W, could this work maybe? I haven't even tried, honestly. Oh wow, this works. Well, that makes things a bit easier. Let's just do that then. Let's define all these like up, left, down, and right. Oops. And put like A, S, and D here. We don't need these anymore. And then that makes things a lot easier and clear. Left, and this would be down, and this would be right. And here I will just put this up, left, down, and right. Okay. Now let's just make sure everything works just as before. Printf, moving and direction, and let's just leave it at that for now. Implicit declaration of change fluffy. Okay, so again, just right like before, I need to put this here. And there we go. Okay, all is fine. Running and bring in. Okay. Okay, now, okay. Now the board gets printed all over again because of this. So I don't get to see this. So let's just comment. Okay. Yeah, so everything works just fine. If I press anything else, it won't work. Okay, great. Now, changing this fluffy direction. Well, I will need Fluffy's old position for this. So location old position equals to m.fluffy. And let's create also location new position, which is for now empty. I will actually need to copy this switch statement and put it here. And yeah, let's just put it direction. No, let's just put it move. No, I'm happier with direction. And this should be direction as well. Yeah. Okay. Now I don't need this. I don't need this. Certainly not gonna use this. Not this and this. So what happens when I move up? What happens to the new position variable? What values should that take? Well, it's quite easy actually. So the new position, so imagine this. Whenever I move up, that means I will not change my column, but I will change my row. So that means only the x variable of this location will change, but not the y. So new position dot x equals to old position dot x minus 1, because we're moving up. So let's imagine that we are here. S is here. If we are moving up, that means S will change rows from row 6 to row 5. But the column will stay the same. Great. So let's just do that. And new position dot y equals to old position dot y. So again, the column doesn't change, only the row does. Okay. I'm going to copy this to the left. So whenever I move left, it's not the row that changes, it's actually the column, and it gets decremented by 1. Whenever I move down, the row gets incremented, but the column stays the same. And whenever I move right, whoopsie, the column gets incremented and the row stays the same. Great. Now you might think that we are done, but we are not, because, well, simple. What happens when I hit a wall? So let's try things. I don't think we can try things now, but let's finish this up. So m.fluffy will become new position. And because I need to update this fluffy variable, I now realize that I can't just pass this maze as a value. I need to pass it as a pointer. And that means that I need to do this. And basically, this is because I need to change the reference of this fluffy variable to a new one. So it's not going to be m.fluffy, it's going to be m-fluffy, and here it's going to be this thing fluffy. And one more thing. So previously, if fluffy were to move around, I would have an X moving around, and in the previous position of where fluffy stood, I would need to put the path variable, right? So that it would be, and it would look empty. So m of blocks of old position dot x and old position dot y equals to path. So let's see what happens now. What is going on? Incompatible type. Oh, bummer. Okay. So when I changed it here, I would have need to have changed it here. There we go. Now it's fine. So let's try to move. Okay. So I'm clearly missing something else. It's not just this, because yeah, things are moving, but I can't see fluffy. So what am I missing? What am I missing? Yes. I'm never actually printing fluffy anywhere. So here, whenever I print the board, I need to put on the board the position of fluffy. So m.blocks of m.fluffy.x and m.fluffy.y equals to player. There we go. Now we're getting somewhere. And bringing it here. Now I'm moving left. Oh, but everything seems to be fine. But what happens? I can go through walls. Oh, that's not great. And furthermore, I crashed because I went beyond the borders of that of the board. So I need to make sure that the position which I'm checking, the next position which I want to move in is a valid one. So I only do this if I have a valid position. So if new position is valid, and I'm going to be sending the new position and the whole board, and I'm not going to be sending a pointer, I'm going to be actually sending the value. So if the new position is valid, only then will I do this. There we go. And again, this is a function which is going to be newly created, and it's going to return an integer. It takes as parameters a location, new position, and also the maze. And actually copying it from here, putting it at the end if new position is valid. Okay. So what criteria do we have to check? So first of all, of course, we need to check whether or not it's within bounds. So the x of the new position and the y of the new position have to be both bigger than 0, bigger or equal to 0, and smaller than the maximum. So let's just write that. New position of x is bigger than or equal to 0, and new position of x is smaller than the dimension of the maze. Great. Also, the same thing for y. New position dot y is bigger than or equal to 0, and new position dot y is smaller than the dimension of the maze in the y coordinates. And also, I want to make sure, I want to make sure that I'm not actually walking through walls. So m.blocks.newPosition.x and newPosition.y has to be different from a wall. Either you write this or you write that it's equal to a path. It doesn't matter, it's the same. I'm just gonna leave it like this. Okay, compiled, everything is good. I'm bringing this here, and voila. Fluffy moves, and it moves quite smoothly. Again, I hope I remember how to get to wherever I need to get. Apparently not this way. Ah, there we go. Okay. So now if I walk on the F, it should signal that I'm done. And it does. I reached the end. Great. So this was about it. I don't think we can actually work a lot to improve this code. Surely not this code. This is like perfect. And you can tinker with the mazes and create something like however complicated or simple you want. Just remember to correlate this these things like the start, the path, the finish, and all that with these. This looks fine as well. This also looks fine. And let's see here. So printing the board, I'm having this switch. I don't like switches. Let's think if we can do it better. I'm very curious if this works in C as well. How about this? I know this looks a bit counterintuitive. Actually, this is the direction. And gosh, could it compile? It does. Woohoo. Okay, now what I did here, and it works just fine. I need to expand this a bit. What I did here was I basically said that in case you hit up, left, down, or right, you just change Fluffy's position based on that direction. Huh. Could it? I think we can just remove this switch altogether. Basically, I can write this like if direction equals to up or left or down or right, then do this. Else, if it's equal to E, then do this. And then do something else. So either, well, that's gonna be a long if statement, but I guess I could write it just to remove this switch statement. Let's just write it like this. If pressed direction key of direction, then I'm gonna be doing this. Okay, else if pressed end game of direction, I'm gonna be ending end game. Actually, you know what? I can just put this here. Yeah, this is fine. So I don't need this switch anymore, but I do need to implement these functions. So let's just put them on. No, yeah, let's just press direction key. Let's just implement it here. Int press direction key of a char. So here I will say this: return either direction is equal to up or direction is equal to left, or direction is equal to down, or direction is equal to right. Okay, so that happens. Pressed end game of direction, again an integer, and then return direction, whoops, direction equals to what did I call it? I didn't even call it. So define end as e and game. Why not? There we go. Okay, so this is how much I hate switch statements, by the way. I would much rather have them in this way, for now at least. Okay, let's see, can I do anything about this? First off, let's make sure everything works. Oh, conflicting types. What? I think I need this. Ah, there we go. Let's make sure everything works. Yes, it does work. Great. Now, let's see what we can do about the other switch statement. Is there anything we can do? Because here, clearly, I have different behaviors. New position starts from old position. And then I don't need these redundant lines. So I trade off one line for 4, which is a good trade, I guess. Let's see, does everything work now? Yes, it still works just fine. Okay. But can I remove the switches? Can I remove the switches? Like this switch. No, I don't think I can, honestly. I mean, I could just write if statements, but it would, yeah, it wouldn't help all that much. So I'm just gonna leave it like this for now, at least. If I have another idea coming up, maybe during when I go to bed, then I'll keep it in mind. But for now, this is it, and the code is okay. It's not bad. I mean, I could write it better in object-oriented programming and maybe doing some gymnastics in C as well, but it's really not worth it. So I'm gonna end it here. As homework for you guys, maybe you could try implementing a jump feature to this game. I think this would be interesting. So let me give you an example. Assume that Fluffy can jump. That means that whenever you reach a wall which has nothing on the other side, so in this case here, and the direction in which you are heading is that way, then by pressing space, for example, Fluffy should jump from here to here. In case you would have had a a wall here, then Fluffy wouldn't be able to jump. So for example, in this case, I can't jump over two positions, but I can jump here, right? Because there's nothing here. And you always jump in the direction of the previously pressed key. So if I press right, a D key right now, and then space, I should be able to jump here. And even if I don't have a wall, if I press the up key now, and I press space or whatever key you want, then I should be able to jump here. So I think this would be a very cute homework for you guys. Just implement a jump feature, and starting, of course, from the code I've just written. Okay? So have fun doing that. And of course, I hope you guys enjoyed it. Leave your feedback either here or during the lab. That's always greatly appreciated. Have a wonderful evening. Bye-bye.